We're going to look at this idea of converse theorems. So converse just means using the theorem in reverse. So with circle geometry, normally we start off, we have a circle and then we use the circle geometry theorems. The converse is going back the other way, where we don't actually have a circle, but a condition for a circle geometry theorem exists. And from that we can conclude, hang on a sec, there must be a circle that goes around all these points, and then that opens up other theorems that you might be able to use. So something like this. If we know that the circle whose diameter is the hypotenuse of a right angled triangle passes through the third vertex. What on earth am I saying? What I'm basically saying is, if you've got a right angled triangle, you know there must be a circle that goes through those 3 points, and AB will be the diameter. Because the situation we have there is angling a semicircle. We just haven't got the circle drawn. So we can say, well, look, I know A, B and C will be concyclic, with AB being the diameter, and the reason is, well, I'm using our angle in a semicircle idea. That therefore means, I mean, there may well be other lines there that we can draw and use, and then go and prove whatever it is we want to prove. This one's reasonably common too. So if an interval AB subtends the same angle at 2 different points on the same side of AB, then we've got a cyclic quadrilateral basically. A, B, P and Q must be concyclic. Again, what am I talking about? This sort of situation. Because what we've basically got there is angles in the same segment. So again, but that one's even more powerful because it makes it a cyclic quadrilateral. And then that then means we know, oh, hang on, opposite angles must equal 180, things like that. So yes, we can say that is indeed a cyclic quadrilateral, and the reason from our angles in the same segment. In fact, you'll find the idea of proving something as a cyclic quadrilateral comes up a lot. Certainly in extension 2 circle geometry questions, but also it happens in extension 1 as well. Another one. You might have a quadrilateral and you notice that the opposite angles are supplementary, or maybe you even notice exterior angle is equal to the opposite interior. So again, that makes the quadrilateral cyclic. So I see something like this, oh, hang on a sec, look at that. 60 and 120, that adds up to 180. So I know A, B, C, D, they're concyclic. Opposite angles in a cyclic quadrilateral, I'm using that theorem. So that's basically the idea of converse theorems, is getting those circle geometry theorems, but using them in reverse to prove that these points all lie on a circle. Alrighty, another quick one.